The engineering mechanics may be divided into statics and dynamics. Force represents the action of one body on another. A force is characterized by its point of application, magnitude and direction. A rigid body is a body which does not deform when subjected to external forces. Scalar quantities are in which it is completely specified by magnitude only, is known as a scalar quantity. Some examples of scalar quantity are mass, length, time and temperature, 4 kg mass, 3.2 meters length, 2 second etc. A quantity which is completely specified by magnitude and direction is called a vector quantity. A vector quantity is represented by means of a straight line with an arrow. Resolution of a force is finding the components of the given force in two given directions. Force systems are divided into coplanar systems and non-coplanar systems. Coplanar systems is again divided into collinear, concurrent, parallel, non-concurrent, non-parallel. Non-coplanar force systems are divided into concurrent, parallel and non-concurrent and non-parallel. In coplanar collinear force systems, these three forces are having a common line of action and in the same plane as shown here. In coplanar concurrent force system, here all the forces are in the same plane and they intersect at a common point O. In coplanar parallel system of forces, all the forces are parallel to each other and in the same plane as shown here. In coplanar non-concurrent non-parallel systems, the line of action of these forces lie in the same plane but they are neither parallel nor meet or intersect at a common point as shown here. A single force which can replace a number of forces acting on a rigid body, without causing any change in the external effects on the body, is known as the resultant force. When two coplanar forces act at a point, R equals resultant of P and Q by parallelogram method. Alpha equals angle between P and Q equals angle between resultant R and P. For right-angled triangle OBA, by Pythagoras' theorem, R2 equals P plus Q cos alpha, 2 plus Q sin alpha, 2. Hence resultant of P and Q is R equals square root P caret 2 plus Q squared plus 2 P Q cos alpha. when more than two forces acts at a point. According to this method, all the forces are resolved along x and y axis, that is their components along x and y axis, and then algebraic summation of them done separately, that is summation along x-axis is given by x squared and summation along y-axis as y squared. Then the resultant of all forces is given by r equals square root x squared plus y squared. An angle made by the resultant with x-axis is given by tan theta equals y x. Lammy'S theorem. It states that, if three forces acting at a point are in equilibrium, each force will be proportional to the sine of the angle between the other two forces. Let alpha equals angle between P and Q and beta equals angle between Q and R. Gamma equals angle between P and R. Then according to Lammy'S theorem, P is proportional to sine of angle between Q and R. P is proportional to sin beta, and Q is proportional to sin gamma, and R is proportional to sin alpha. Then P sin beta equals a constant. Q sin gamma equals a constant, and R sin alpha equals a constant. P sin beta equals Q sin gamma. Moment is the rotating effect of a force. The effect of this force is to rotate the body about O in clockwise direction. If the direction is reversed, then it will be in anti-clockwise direction. If L equals perpendicular distance between line of action of force F and point O, then moment of force F about point O is m equals F into L, Newton meter. Varignon'S theorem. Varignon'S theorem states that the moment of a force about any point is equal to the algebraic sum of the moments of its components about that point. Let the resultant of forces P, Q and R acts at a distance x from point A. Then by Varignon's theorem, taking moment about point A, S into x equals sum of all the moments of P, Q, R about A. In this case, all moments will be in anti-clockwise direction with respect to point A. S equals resultant of forces P, Q and R. Equilibrium is the state in which opposing forces or influences are balanced. Equilibrant is a force equal to but opposite to the resultant sum of vector forces. It is this force that balances other forces, bringing a system of forces into equilibrium.
The three concurrent forces F1, F2 and F3 are acting on a body at point O and the body is in equilibrium. The resultant of F1 and F2 is given by R. If the force F3 is collinear, equal and opposite to the resultant R, then the body will be in equilibrium. The force F3 which is equal and opposite to the resultant R is known as equilibrant. Free body diagram of a body is a diagram in which the body is completely isolated from its support and the supports are replaced by the reactions which these supports exert on the body.